everyone, my name is Camden Glenn. I'm a senior at Doane University, and for my senior research project, I decided to do an analysis on the history of probability and statistics. So the goals of this project is to explain how various people, events, and concepts shape probability and statistics as we know it today. And this history can be divided into three distinct timelines. The first being over the origins, decline, and preservation of ancient probability and statistics. The second being over the revival, foundations, and building blocks of what would be modern probability statistics. And the third being over the dawn of modern statistics and where we are today. Slides will be color-coded in respect to which timeline we are currently in, as you can see right here on these slides. So the origins of the practice goes all the way back to ancient Xia China and city-state Greece, where these states used the collection of census data or statistical data to improve their administrative efficiency, like with collecting taxes, and military drafting of their population. Rome would expand the collection and application of this census data from just its population to its land, which it then used to improve its land maintenance and division, which would evolve to be the feudal system, and for the maintenance of its infrastructure, such as roads. By the 5th century, however, most centers of learning ended up disappearing as a result of a societal collapse, with a couple of exceptions. These exceptions included the Arab Ummah culture, which grew after the Islamic conquest, and they ended up preserving most Hellenic texts in northern Africa and such. In Western Europe, Catholic monasteries also preserved ancient Hellenic texts, but also on a societal level, like with the peasantry and nobility, there was a popular gambling culture that existed, which would be important later. And the Eastern Roman Empire, also known as Byzantium, survived as the main center of learning and knowledge until the 15th century, where it was conquered by the Turks. With this conquest, a transfer of texts and scholars to the West ended up triggering a Renaissance. And once this information mixed with people who were interested in the gambling culture that existed in Western Europe at the time, is when the first mathematicians that were interested in probability and statistics emerged, such as Pascal and Fermat. As I mentioned, they took an interest in gambling and saw in these texts that had started coming to Western Europe as key to developing a better understanding of these games. And so they ended up developing concepts like Pascal's triangle, binomial expression, and binomial coefficients, which would act as some of the building block concepts for probability. However, progress in this math was not very consistent until about the 18th century, considering that there was a conflict between these mathematicians and the European Church, namely the Catholic Church at the time, and their charge was the sin of usury, which essentially states that if you are knowingly taking advantage of people, then you are committing sin. And since many of these mathematicians sought to create a better understanding of the gambling culture, namely the various games that are in that culture, the church saw these individuals as people who could potentially be taking advantage of those who don't have an understanding of these games. And so progress in the development of probability was stagnant until about the 18th century, until Abraham de Moivre enters the picture, when he developed the classical theory of probability using Pierre and Fermat's concepts, as well as other mathematicians who came from before him. The classical theory of probability was defined as creating an understanding of the measure of a likelihood of something happening, and that every experiment contains events that are equally likely to happen. After Abraham de Moivre, the next important mathematician is Thomas Bayes, who is important for his work in continuous and conditional probability, as well as the development of his Bayes theorem. And while his work is important for statistics today, or probability, he was also a controversial figure because of this work. And because Bayes was a controversial figure, it ended up creating a conflict with the mainstream probability community, and eventually a split between what would be known as the frequentist and Bayesian theory. Now, what the series entitled was that for the frequentist theory, a probability is determined by the frequency of an event, and data is random, and confidence intervals determine the parameters. And one thing that this ultimately entails is that you can only use data, observable data, namely, to determine what your assumptions and your conclusions will be, and you can only have one answer. Whereas with the Bayesian theory, you can have a combination of both observed and unobservable data in your distribution, and as a result of this, you can have multiple answers based on whatever your assumptions are. So with this conflict between these two theories, we have what we can see nowadays almost like rivaling sports teams, whether it be baseball or football. Like in baseball, I think the Red Sox versus the Yankees is a good example. Don't quote me on that, but that's essentially what we have at this point. Is we now have two different theories of probability and later on statistics. So after this divide in the probability community, this is where mathematicians also start to become eugenicists at this point. People like Francis Galton, who was originally a eugenicist, began to take an interest in what was starting to develop as statistics. And the reason why these mathematicians started to take an interest in statistics is because they saw probability as an important tool to proving eugenics. This would become most prevalent with Carl Pearson eventually, where he ended up being credited as being the founder of the modern discipline of statistics for organizing the community of mathematicians that were interested in probability and statistics into a formalized group. He was not recognized as the father of statistics, that person would come later, but he was credited for bridging statistics to other sciences like eugenics and for creating the following concepts as well as organizing the community. As I said, Carl Pearson was not credited with being the father of modern statistics. That honor goes to Roland Fisher. And the reason why Carl Pearson wasn't credited was because he didn't create a coherent theory for what statistics should be defined as a practice, like what De Moivre did for probability. Roland Fisher fills this role, but he was also a strong critic of both the frequentist and Bayesian theories. He criticized frequentists for disregarding the conditional element of Bayesian theory, which he saw as a useful tool for furthering the development of what was starting to become known as statistics. But he also criticized Bayesians for the use of unobserved data and variables in experiments. This made it an unpopular figure with both followers of the Bayesian and frequentist theory, but he ended up contributing several concepts to the mathematical community, and namely by formulating the modern theory of statistics. This theory created a distinction between samples and populations in statistical experiments. It formalized the system and practice of collecting, analyzing, and verifying the conclusions and results of a statistical experiment on samples and populations. And it created a focus on specifying, estimating, and distributing samples to possible interpretations of that said data. However, as Roland Fisher was a controversial figure, he ended up kind of getting teamed up by the Bayesian and frequentist theorists. So he was, as I said, a widely unpopular figure. Until, of course, Gertrude Cox enters the field. Gertrude Cox would eventually get Roland Fisher recognized as being the father of modern statistics, as at the time she was an influential member of the American Statistical Association and the British Royal Statistical Society. Thanks to this influence, she ended up being responsible for spreading and popularizing Roland Fisher's work outside of Britain, and she was also an important figure for integrating Fisher's theory into the American education system. So from this point on, we have another division within the probability and statistical community, where with Thomas Bayes, we have a split between Bayesians and frequentists. Now we have a third party, a third team in the game, being with the Fisherian theory, where the Fisherian theory would become the dominant theory in most education systems in the West, thanks to Gertrude Cox. And with the spread of Roland Fisher's theory, Fisherians started, and other statisticians at this point began to integrate the different theories to see what they could come up with. A couple of hybrid testing methods that developed after Gertrude Cox included empirical Bayes, gamma minimax, and restricted risk Bayes. I'm not going to go through all of them, but an example with empirical Bayes is that it uses frequentist reasoning, or the frequentist process of proving an experiment, to justify your assumptions and a Bayesian answer. And some hybrid concepts that began to emerge included conditional frequentist, model selection, and I can't read that. Hold on. P-values. Conditional frequentists was a concept that reported any data-dependent errors, probabilities that existed in an experiment, regardless of what the theory that was being used in that experiment, to support the data and your conclusion. So at this point, other statisticians that began to emerge were John Tukey. He was namely responsible for the development of the box plot and other concepts related to it. But he was a mathematician that opposed Fisher's strictly data-driven approach to statistics and wanted statistics to be much more of an applied field. This would start to become more of a reality by the 20th or 21st century, with mathematicians like David Blackwell, with the development of his Blackwell renewal theorem, and the Rao-Blackwell theorem, which operated as a tool for bridging statistical concepts to engineering, where you can now use statistical concepts and experiment methods in engineering, as an example. So in summary, probability and statistics started out as an administrative science that was widely used for improving the administrative and military capacities of ancient countries. After the 4th and 5th century societal collapse, most knowledge and techniques related to this science was lost, and it started to come back by the 15th century with the fall of Byzantium and the migration of old knowledge and texts to the West, triggering a revival of probability during the Renaissance, when eventually de Moivre formulated the classical theory of probability, which became the formal theory of probability as we know it today. By Thomas Bayes' time, he ended up creating a controversy which created the first divide in probability and statistics between what will be known as Bayesians and frequentists. And then later on, eugenicists would become the main mathematicians at the time, so that way in order to prove eugenics using statistics and probability. And Carl Pearson would become the founder of the discipline due to organizing most of the community. By the 20th and 21st century, Fisher comes into play, where he formalizes the modern theory of statistics, where in the process of creating a second divide, where Fisherian theory becomes a third party in the statistics and probability community. Cox, however, is responsible for the spread of his work and ultimately the recognition of Roland Fisher as the father of modern statistics. Statistics shifts from being a hard science under Fisher theory, where it's just applied to statistics or as a purely mathematical science, to being more applied later on. And by the 2000s, statistics has become more of a hybrid science, where it uses all the theories and is applied to many different disciplines such as engineering, computer science, so on and so forth. And here are my sources.